In part 4 of lecture 1, we will take a look at Shaper and its scanner. Let's take a look at an example of a translator. Shaper is a microscopic language, and the only thing it's really good for is drawing small rectangles, squares, and right isosceles triangles on the screen. It really doesn't serve what you call a really useful purpose other than to illustrate how translators work. The language is actually fairly simple. There are 3 different types of statements: rectangle, which is followed either by the word wide or long, and then a number, an integer, the word by, and another integer. We have to state in advance if the rectangle is long or wide. Long means that the first number is greater than the second. Wide is the other way around. Now that seems to be sort of useless other than giving the opportunity to make mistakes. But this will allow us to do a very simple check of the data type to make sure that it's what it's supposed to be. A square, size and a number, triangle, size and a number. And you can see below 3 simple examples. It is a compiler, sort of, in the sense that we have to save a program in a file, but it's an interpreter in the sense that it will actually draw this on the screen rather than generating code to do that for us. But it will allow us to take a look and see examples of at least a good portion of what you'll have in a compiler. Let's take a look at the Shaper translator. This is written in C++, and it starts out, not surprisingly, with a certain number of #include preprocessors, IO stream, the input-output stream, F stream for files, C type, so you can look at the particular type of character, C standard library, we'll get to that a little later, strings, both the type that is arrays of characters ended with a null byte, and the C++ string class, as well as C's standard library. We have to have, as always, using namespace standard. And what you'll see here also is a representation for the tokens of the language. It's an enumerated type, essentially meaning that we have tok by is 0, tok EOF is 1, and so on. We begin all of these with the abbreviation tok, T-O-K, to indicate that these are tokens. When debugging, it proved very useful to be able to print out the names of the various tokens. We have here an array called token name. It's an array of strings, and you can see here by, EOF, and so on. And if I use the token itself as the index here, I can print out as a string the token in question. When you're debugging, this becomes very useful. We have here file name size 40, token string length as 15, and there are 10 tokens in the language. Here you can see the methods and the properties for the class scanner. We have the public ones, first of all, 2 different constructors where we can either give it the command line parameters or not, and in either case it will open the file for us. We also have a destructor to close the file, and scan, which is what the parser will call to get additional tokens. Privately, we have word search, which essentially is an array of all of the tokens, which is essentially going to be our symbol table. We have scan word and scan num, which handle the detail of scanning words, which are sequences of letters. Please note that these all being reserved words, we're not going to have a mixture of alphanumeric characters in it. And scan num, which will scan number. There's no reason to scan operators because Shaper doesn't have any operators. Lastly, we have an input file object called inFile. Here we have the default constructor. Its procedure is fairly straightforward. We prompt the user for a file name, and then we read it in. We open the file, and if we are unsuccessful, we print an error message that we couldn't open it, and then we exit. Here we have the constructor that makes use of the command line parameters. Since they are accepted by the main program as the count of arguments and the array of strings with them, this is how we have it here, using C-style strings instead of C++'s string class. Our one local variable you see here is the file name. If there's only one parameter, that's okay. We didn't read in the file name when we called the program, so we'll need to read it. If there are two, the second one will be the name of the file. And if there are more than two, this is clearly a mistake and needs to be flagged as such. Here you see the if-else construct, where we check the number of parameters we've counted, and we deal with it appropriately. If it's only one, we need to prompt the user for the file name and read it in. If it's two, we simply copy over argsub1, the second parameter, which is the file name. If it's anything else, we print the error message that the usage is shaper and then the name of the file, and we exit, giving the code 1 to indicate the problem. If there were either one parameter or two, we are now ready to open the file. We open the file, and if for any reason we were unable to, we print the appropriate error message, and again, we exit. Here you see the destructor, the method that is automatically called as we deallocate storage for the object in question. All we need to do here is simply close the file, and that's exactly what we do. When we go to scan for the next token, you'll notice that we have one parameter here, the token string. Writing it this way allows us to return the token as the result of the method, but at the same time, passing by reference, we can also return the token string because there will be a need to make use of it for other things. We read in the first character, and given that we are using the get method, we are not going to be able to get an accurate read from end of file until we've gone too far. In this case, what we'll do is that if what we get back is, as an integer, is -1, it indicates we've reached the end of the file. We also check to make sure that it is a whitespace character, a blank, a tab, or a new line. If it is one or the other, and as long as there's more of the file to read, we keep reading until we finally get a character that's good. Now, if it's the end of the file, the token we return is toc end of file. There is no reason to continue beyond this point. That first character is crucial. If it's a letter, it means that we're going to be reading in one of the commands of the language. If it is a collection of characters as anything else, or if there's a number of some sort, that's going to be a mistake. If what we're reading is a digit, that indicates this is a number indicating the size of one of the dimensions of the shape. If it's anything other than a letter or number, it is obviously a mistake, and in that case the token we return is error. In the two other cases, we call scan word or scan num, which will respectively return either a word or a number. We can leave some of the details there to deal with shortly. Scanning a word means that we will keep scanning until we find something other than a letter. What we will then do is use a binary search to look through the array of command words to see which one we have found. Its index then will be a representation of our token. We begin by taking as parameters the first character C and the pointer to the array token string. This is important. This will allow us, as we said before, to return the token as the result, and using a reference parameter to hand back the string, which may be useful for various reasons. We have two integer variables here. I is our index, which we will initialize to 0. Token code is what we're going to end up passing back, and token class is going to be the actual token that we will make use of. The token string will initially be just that one character that we read. We get the next character, and as long as it is not -1 indicating the end of file, and as long as it is a letter, we attach it to the end of our string, and we get the next character. Once we reach a point where we either have reached the end of file or a non-letter, we place a null byte at the end. This is a C-style string. Next, we will push back that last character, and that will be where we start the next thing that we scan. Now let's take a look. We use word search to see if we can find this token string within the array. If we can, then all is good, and we return the token associated with that word. If it's not there and we got a value of -1, we return the token error because what we scanned is not a correct word in the language. Now let's scan for a number. Our first character was a digit, and what we will now do is start out by placing this digit in our string and then preparing to read more. We get the next character, and then we check to see and make sure that it is not equal to -1, indicating the end of file, and that it is in fact the digit. If so, we place it at the end of the number that we're building, and we get the next character. When we get to that end, we place a null byte at the end again to end the string properly. That last character is pushed back on the stream, and we return the token number. Our symbol table is essentially just an array of strings. These strings are words within the command language. If it is there, we know what the token is going to be. We simply take the token type from the index in the array. If it's not there, we'll return -1, indicating it's not there. And that, as we saw before, will give us a token of error. We have three parameters here: the word that we're looking at, the array of words we want to see if it's contained within, and the length of the array. We set low to 0 and high to len -1, the lowest and highest index that we're searching through. And as long as low is less than or equal to high, we haven't searched the whole thing yet. We set mid equal to low plus high, all of it divided by 2. If low plus high is odd, we're going to truncate and get rid of that half at the end. If the word is less than the middle word, we search the lower half of the array by setting high equal to mid -1. We've already made sure that mid is not the word we're looking for. If test is greater or comes after the middle word, then we search the upper end, and low is reset to mid +1. Again, we know mid isn't it. If test is not greater than or less than words mid, it means we found the word we're looking for, and we return mid. It is the index of our word within the array. Of course, if we returned -1, we've crossed through all of this and it's not there.